Welcome to our talk, Real-World Security, Software Supply Chain. My name is David Lawrence. I'm on the security team at Docker.
My name is Daniel Shapiro. I'm a security researcher at Whistlock.
So what are we going to talk to you about today? We're going to start with what is a supply chain. I realized I've done probably 4 or 5 supply chain talks now, and I don't think we've ever actually given an overview of what are the components within a supply chain. We've always just kind of assumed you know what we mean and you know what the components are doing. We'll then go over a quick threat model, and for the security people that I know are in the room, and for the ones that I don't know are in the room, this is going to hit the highlights. This is not going to be a comprehensive security model. This is really just going to be the key things that you should be looking at for the people who are maybe less well-versed in doing a threat model. Daniel's then going to present some research that he did at Twistlock on the open source Docker Registry, and a deployment problem that was discovered with that. And then we're going to finish up with some best practices that will help you secure your supply chain, and particularly the distribution elements of it. So first up, what is a software supply chain? Now, I wanted to come up with a metaphor to talk about supply chains, because if there's something that we all sort of intrinsically understand, it can be easier to grasp the idea when we transfer it into the software and digital world. So I really like food, so I'm going to talk to you about supply chains in terms of a restaurant. And it turns out that restaurants map really well to supply chains, both in terms of the process and actually in terms of the way they get compromised. So restaurants start with a chef. Chefs essentially come up with algorithms. They come up with sets of instructions to make plates of food. And our chefs will source their information from works of art such as Mastering the Art of French Cooking, and of course, as all of us know, the relevant Stack Exchange. The output from that is a recipe. And a recipe is human-readable code that can be used to perform a process, and in this case, the process is building a plate of food. This recipe goes into a recipe book, which is essentially a version control system for our restaurant. The version control system being the actual tangible thing, this is the first component of our supply chain. That gets passed off to our continuous integration service. These are our line cooks building the plates of food to the recipe over and over again. And if our continuous integration service is working properly, given the same recipe and the same dependencies, which are the ingredients they need to make that recipe, they will produce identical plates of food every single time. Having created their plates of food, they put them into the distribution center. And in a restaurant, this is the pass. The plates of food sit there until eventually the final piece of our supply chain, a server, pulls them from the pass and deploys them to the users. So what does our supply chain look like? Well, it has 4 components. We have a version control system, which is where we as developers store our code, or where our chef stores his recipes. We have a continuous integration service, which takes our code or takes our recipes and builds our applications over and over again and pushes them into our distribution center, which for us as Docker users is going to be a Docker registry, whether it's Docker Hub, the open source registry, or you're a Docker Enterprise customer. And then there's the final component, which is our servers that take the artifacts out of our distribution center and deploy them where relevant. Now, why do we care about software supply chain security? I think it's very easy to focus on the applications that are running and making those secure. We talk a lot about things like secrets, encrypted overlay networks, but it is also critical to secure the entire process that got to that application being created. Because you can imagine in our restaurant, if the food is contaminated at build time, when our line cooks are taking it out of their fridge and using it to make a plate of food, that contamination is carried through the rest of the supply chain. So the earlier in the supply chain something gets affected, the more pieces of your supply chain it can potentially compromise. And if we look at the attacks that have happened on software supply chains in the last decade or so, we not only see that, one, they're common, but they're actually increasing in frequency. I mean, it used to be there were 1 or 2 a year. I think, transmission getting compromised twice last year was particularly funny. We can see in 2017 there's been at least 6 already, and I think there's been another 1 or 2 since I actually put this slide together. This was a month or 2 ago. I think my favorite one of these is actually Express Lane right at the top. Has anybody heard of Express Lane? No? It might be better known in the US. So the CIA is actually a software vendor to other US agencies, particularly intelligence agencies. And Express Lane was a program where they would send an agent into those other agencies to perform a software update. And as part of the software update, they would also install a backdoor. And they would then use the backdoor to make sure the other agencies were sharing all of their information with the CIA. You know, it's a nice way to keep them all honest, right? So let's look at our software supply chain threat model. And one of the ways of doing a threat model is to start by breaking down your application into three sort of sets of components. The first one of these is the entry points. How can somebody actually interact with the components within our system? Because this is how they're going to be able to affect operations. For our version control system, these are the inputs that get into our code and the API for whatever our version control system is, whether it's Git or SVN or Perforce. I hope nobody still has to use that. For our continuous integration service, this is largely build time dependencies. This includes things like base images, but also software packages you're going to be installing from Linux distributions, and obviously the API that enables you to trigger builds within your version control system. And like I said, particularly these build time dependencies are especially important, because if one of those is compromised, you've already introduced vulnerability into your supply chain, into your applications, pretty early in your process. Our distribution center, the only way to interact with it is a very simple API. Whether it's in the restaurant or it's a Docker registry, there are two operations you can do against it. You can put something into it, and you can take something out. And that's really it. And finally, we have our servers. And if you're deploying these properly, you shouldn't be allowing users to SSH in. You shouldn't even have SSH set up on them. You should be deploying them using something like LinuxKit to give you a very minimal Linux distribution. And you should be deploying Docker on top of them and having Docker be the only mechanism for interacting with your servers. Next up are the assets. These are the tangible things that we want to protect within our system. For our version control service, this is largely proprietary code. For the continuous integration service, if you're doing it correctly, you have infrastructure as code. So you have the actual build instructions for your continuous integration service checked into your version control system, making continuous integration a relatively stateless process. However, you probably have some secrets on here, secrets that are going to allow your continuous integration service to access your proprietary code from your version control and push the built artifacts into your distribution center. And speaking of the distribution center, in your Docker registry, the images are the thing you want to protect, right? This is really the only thing it intentionally stores. And then on your application servers, we get the much broader scope of assets. We have users' personally identifiable information. We have secrets that allow your servers to access other services within your system. And secrets are particularly important to protect because a lot of attacks, once they get an initial foothold, they will move laterally within your infrastructure. This means moving to another service using information they've attained or poor permissions once they get past your initial firewall. So secrets can, if not properly protected, can really help an attacker to further get compromises within your system. And then compute. A lot of attacks these days are simply looking to find compute resources that they can mine, Bitcoin or some other cryptocurrency on. And the last part of our sort of threat model input is the data flow. How does information move through the system? And this is where we really see that a compromise early in our supply chain affects all the subsequent pieces, because data flows from our version control system to our continuous integration system, to our registry, and eventually out to our servers. There's no way for us to remove a compromise once it's been introduced because of the direction the data flow gets pushed through. Although we will look at some tools later in the best practices that are going to sort of help you manage and detect risk there. Now, we're all busy people, right? We have to focus our efforts on the thing that's going to have the most impact. So while it's tempting to go and try and do all of the things and secure every piece of your supply chain as well as you possibly can, and there are absolutely some basic things you should do, like enable two-factor auth on your version control system, we also want to optimize our time and work out what is the #1 thing that we should be looking at today. And maybe the attacks we've seen so far can give us a hint about this. because I would expect to see attacks going after the weakest link in the chain. This is kind of a paradigm in the security world, is that the weakest thing is always the thing that's going to get attacked the most. And I'll give you a little hint first through the form of an anecdote. When I was driving down to San Diego with my fiancée at the time, now wife, to go to our wedding, we stopped in a well-known American fast food chain. And against all her better judgment, she ordered a chicken salad. You never order a chicken salad in a fast food chain. Later the same night, she woke up with the most horrendous food poisoning. Fortunately, she recovered before the wedding. That was fine. However, this led me to think, where did that vulnerability, because food poisoning is a contamination of the food, it's essentially a vulnerability. Where did this get introduced? Well, I mean, it was probably in the ingredients, but all ingredients have some forms of bacteria and other things on them. More than likely than not, the issue was that it sat in the distribution center for too long. This is bit rot, right? This is software that's introduced into your distribution center with vulnerabilities that haven't been discovered yet, and it sits there and bit rots. And if it sits there long enough, the vulnerabilities become exploitable because people discover them. So, which bit of our system is the most vulnerable? Well, when we look at all the attacks, we see that the vast majority of them have been going after the distribution center. And now, they're not specifically focused on bit rot, but they have gone after the piece of the system that tends to be more sort of frontline. You can get access to it, certainly to get the information out more easily, which is probably one of the reasons that it does get attacked more. It's more exposed. So, our distribution center is the open source registry, and Daniel's done some research on that. So Daniel, why don't you tell us about how you did your research and the findings that you had?
Right, cool. Thank you, David. So first I would like to bring up some points from the past, very relevant hacks. The first one is MongoDB. The MongoDB was released back in 2009, and they fixed an issue that allowed 18,000 instances of MongoDB being hacked, only after 7 years. The second one is Redis. Redis released back in 2012, and they took them 3 years to fix an issue. Even after they fixed this issue, 28,000 instances have been hacked by hackers. That happened because people actually did not upgrade their software and kept using the old version.
So this sounds exactly like the bit rot we were just talking about.
Yes, exactly like that. The third issue I would like to bring up is the Mirai botnet. You're probably very familiar with it. It made a lot of headlines in the papers. Mirai botnet got control of almost 400,000 routers, and there is no patch coming out. No one even expects it. So what is the common denominator of these 3 events? Well, it's weak defaults. Mongo was released without authentication at all. So once you spin up your Mongo database, everybody could connect to it and steal your data or manipulate it. You actually can read about it in the papers right now. Last Christmas, another 20,000 have been hacked because of this issue. With Redis, it's the same thing. Redis, no authentication at all. The Mirai botnet is a little different because routers actually do have authentication configured. But the problem is that they are configured with very weak passwords, like admin or admin1234. And you can actually gain these passwords by Googling the router model, for example. I would like to speak about the research motivation right now. So as we see with these 3 events, usually people do not change the default settings. Another thing is that Docker popularity is rapidly growing. So we expected a lot of more people to actually spin up their applications easily with Docker run commands and just leave the default settings. So from another angle, there is a great talk by Daniel Garcia and Roberto Munoz. They talked about Trojanizing Docker images at RootedCon earlier this year. Essentially what they did was to break down an image, inject malicious code inside, and pack it back up. So I thought to myself, what can you do with this image? And the interesting thing that it really got me going is if you get inside the registry, you can actually distribute this Trojanized image all over the organization. So what we actually can do once we have access to the registry? So as David said before, there are only two actions you can perform. You can either pull or you can push. So you can actually pull on all the images that are hosted there. So I can get your images, I can break them down, I can actually understand what you are doing. So if there is a proprietary application, I can actually steal your code now. Another thing that I can do is, as I said, Trojanize an image and push it back to the registry. And now your organization is going to pull this image, and I'm going to take control all over it. Another interesting insight that I saw is that the registries are not limited to host only Docker images. You can actually push any file on it, and it's going to go and sit there. So, for example, I can use it to distribute any malware. I can push a macOS malware there and use your registry as a server to distribute this malware. So, what is the situation of the Docker registry? Well, it turns out there is no authentication on it at all. So, if your registries are exposed to the internet, anybody can go over and take control over your organization with them. I would like to bring up the research methodology. The first mission was to actually identify the Docker registries. So how do we do that? Docker adds this HTTP header to the responses of any HTTP request that you will send to it. So once we know that this is how it responds, we can utilize Shodan.io in order to find potential targets. If somebody doesn't familiar with Shodan.io, it's essentially a search engine for internet services. So you can actually just put this header into the search engine, and it's going to return to you a long list of results. Once we have this list of results, we can utilize the registry API in order to understand exactly what the authentication status of this registry is. And it's good to point out that Shodan.io is actually limiting results. So you can't scan the whole internet with it. It's going to limit you, and it's actually show you the results only 2 months back. So these findings do not represent the real world. It's just a subset of the real world. Let's see what we have found. So just using Shodan.io, we found over 1,000 open registries. 60% of them were completely misconfigured, so you could actually do whatever you want with them. Only 30% were kinda configured correctly. You could pull the images, but you couldn't push them to there. Only 10% of them were actually configured correctly with good authentication. And 45% of these 1,000 registries belong to big companies. And we didn't even scan the whole internet. To fight this situation and help your organizations to actually detect these misconfigured deployments, we present a tool, HazAuth. HazAuth is an open source tool. The Git will be published later. It's not available now, but you can pull the image, the Docker image, and use it. It's a modular design written with Python. There are plugins available. You can write your own plugins if you have your proprietary services or something like that. Redis is available right now, MongoDB, and Docker Registry. So I would like to show how this tool works. So I'm going to run the image right now. I disable the content trust because we did sign our image, and I'm mounting the Docker socket with read-only permissions because we need to actually communicate with Docker daemon in order to understand which containers you are running right now. As you see, twistlock-HazAuth is the image, so you can pull it right after this talk and check it yourself. You can see that it has found 3 registries. Only one of them was actually configured correctly. And you can see that the 2 others are open. From another angle, we also worked together with Docker in order to provide a safer and secure environment with the default settings. So what we did, we implemented HTTP password generation inside the Docker registries. So once you run your Docker registry, what's going to happen is that we are going to generate a password for you, and it's going to be printed to the std out. Very similar to how Jenkins works right now. Back to you, David.
Yeah, so fair warning to everybody here. Go back to your operations teams, tell them to run the HazAuth tool, but also tell them we're going to be releasing an update in the very near future that if they just arbitrarily upgrade and they're not currently using authentication and authorization on their open source registry, they're going to break, and they should expect that. But we're doing it because apparently a lot of people are deploying these things in bad configurations. Misconfiguration is one of the OWASP top 10 security problems. So looking at a few additional best practices, things you should also be doing. TLS, right? Passwords are great, but you really don't want to send them over a plain text network connection. For those that aren't familiar, Let's Encrypt is a public CA that will issue domain-validated certificates to you for free. And the registry, the open source registry, comes with Let's Encrypt integration. So I was going to show you how incredibly simple it is to get this set up. Hopefully the internet, yes, the network is working. All right.
It's not showing on the screen.
Oh. I guess I have to stop the presentation. Got it now? Yeah, there we go. Perfect. Okay. So, I wrote a file here so that you guys could actually read this properly. So, we can see here there's just 3 additional environment variables that you need to set. You actually don't even need to set the cache file as far as well, you have to set it, but I also mount it as a volume. So on container restarts, you actually do get true cache. This is just where Let's Encrypt is going to write the certificates and keys and other things that it gets or generates and gets from Let's Encrypt. This is the email address that's going to be used to register for the certificate from Let's Encrypt. And then you have to give it a host name. So you do additionally have to do DNS setup. But with these 3 parameters set, you can get the open source registry on startup to go and get you a TLS certificate. So we can run this quickly. And that's our container ID that's come up. We can curl this container. And we'll see in the verbose output, we went and got a certificate. It's registered to the host name that I had configured in that environment variable. And it was issued from Let's Encrypt. So it really is that simple to set up TLS on your registries. And before anybody tries to go and put anything in that registry, okay, now it doesn't exist anymore. All right, so additionally, for everyone who's in the keynote this morning, and I think it's been shown in a few other talks as well, you should be using Docker Content Trust. We are making it easier. This is the current status of the Docker Trust command that's going to be released in the very next release of Community Edition, 17.10. It has sort of the 3 basic operations. Sign something, remove the signature from something, because one of the benefits of the signing mechanism that we've implemented is that you can actually sort of unsign. It's not really what you're doing, but that's a whole other talk. And then you can also view the signing information. In subsequent updates, we're going to be giving people drastically improved commands for managing collaborators. So if there are any Docker Enterprise users, it's going to become much, much simpler to start using signing policy. And then finally, use Docker security scanning. And this is the bit that's going to help you with that bit rot. In addition to using bad build time dependencies, Docker security scanning, for those that don't know, takes your image, breaks it down into what we call a bill of materials, which represents all of the components within your image. It actually looks inside binaries even to find statically compiled libraries that have been built into a larger binary. It scans that against a database of CVEs, common vulnerabilities, and I always forget the E, and exposures, that's the one. I can never remember the E. Because all the other ones, it's enumeration, like common platform enumeration. Anyway, too many acronyms. So it scans it for CVEs and then gives you a notification if it finds anything. It also keeps that bill of materials around, and as new CVEs are discovered, it goes and regularly checks the bill of materials against the updated database. So it's continually checking for that bit rot. When CVEs you didn't exist yet, but apply to software that you've built, when they come out into the open and they're known, you're going to get a notification and you can get on with updating your software. So this was everything we had. Thank you very much. We have plenty of time for questions.
Yeah. No questions? All right. I guess not.
No. Throw a hand up. Shout.
Yeah.
So,
There's other vendors that now it works. There's other vendors that provide similar solutions. How can I choose? What's your proposal there?
I mean, if you're already an enterprise user, security scanning comes with it, so it's kind of convenient. We are actually working in an open working group called SIG Scanning to sort of modularize and turn scanning into more of a pluggable thing. So there is work being done to enable people to integrate with other scanning providers, like even as a Docker Enterprise customer. If you're interested, we have a Moby discourse forum, and you can look up SIG Scanning. SIG is a special interest group. And if you post on there, I'll get a notification. I can make sure anyone who's interested is invited.
Okay, thank you. And a second question, if I may. This is static scanning. Are you also working on runtime?
So this is one of the... Oh, sorry. I thought you were going to say dynamic for a second. I was preparing for that.
Well, you can answer that one as well. I'm interested.
Yeah, so we are... Runtime analysis is one of the things that we're kind of more leaving open to the security vendors, building tools that will run in your infrastructure and monitor an application, see what its behavior is, and build policies out of that. As far as, I guess it's still static analysis, but scanning interpreted languages. Again, this is one of the reasons why we're actually working on SIG scanning, is because we want to give people the ability to pull in scanning providers that have other pieces of functionality. I would say those are two separate things, though. The dynamic analysis, because it's going to happen within a running cluster, and you're going to want to have things like networking plugins, volume plugins, something that can monitor every single operation the container is doing. It sits in a very different part of the infrastructure. That doesn't mean it won't necessarily have a feedback loop that in some way, adds additional security properties to the image.
I understand your answer, but it triggers me. I can also imagine that you would want to have some sort of policy while building the image, disallowing certain runtime operations. Is that there? Have I missed that? Or?
It depends what you mean by runtime operations. I mean, we support a lot of the Linux, I don't say capabilities, that is, we support Linux capabilities, seccomp, Linux security modules like AppArm and SE Linux, and those are the typical ways that you would limit how something actually runs.
Clear, thanks.
A question regarding authentication, or the tool that checks the configuration of the pre-registry. Did the check also provide some hints where the problems are and how to become a secure registry?
Well, first of all, after the patch, you will be secured by default. So there is actually no recommendations how to do it. But you will know which registry is not configured correctly. There are numerous documentation on how to configure it securely. Just people do not tend to read them. And that's why the world looks like that right now.
Hi, just a quick question about, you mentioned weak defaults being the cause for some of the hacks that we've seen in recent history. I was just wondering about the default setting of the user for a Docker image being root. Would that be considered a weak default? And if so, what ways can we mitigate that weakness?
So, in a perfect world, and actually I was asked this question yesterday, and it came up in the security panel as well. We've never actually seen a container breakout in the wild. We've seen academic ones. So the idea that running as root is a problem, I mean, it's imperfect, certainly. But we haven't actually seen anybody manage to get out of a container and use it to then go on to further compromise the host. That being said, would you run any of your current applications as root? Like, Probably not. But you might log onto the machine with an account that has root privileges that does all the configuration to get them started up. So my question is, like, why isn't everybody doing the same thing with their Docker images? You can put one line in your Docker file, that is then built in to your image that says, run this as a different user. Please do that.
Follow-up question, would that possibly be part of core at some point? Would that probably become maybe a default that it's a non-privileged user instead of root?
Containerd, interestingly, actually supports user namespaces per container. So I would say the thing I would envision happening is that there's just every container is given its own user namespace by default. I think that's what I consider the most likely outcome there.
Thank you.
Yeah, thanks. So you mentioned Let's Encrypt. Is there a way to configure with a different CA that is potentially could be enterprise approved?
Absolutely.
Okay, so
Let's Encrypt is built in as a sort of quick and easy option if you don't want to go through the additional steps, but you can absolutely configure in your own CA.
got it. And so when you do security scanning, is there a way to, and I don't know if you do that, right, to look for potential certificates that have been generated with the non-approved CA for a security team?
Well, so the Let's Encrypt certificate is generated at runtime.
Right.
So, I mean, the short answer is no, security scanning doesn't have anything like that.
Okay.
That would be sort of a very, very customized
Right, because if you think about it from the security team, right, if they have a policy that is guided by the enterprise, and then you have DevOps teams go out and essentially get certificates from Let's Encrypt, which is not approved, it kind of creates this unmanageable situation.
Yes. Yeah, but again, it's a runtime configuration, so even if you did the checks in scanning, they could still go and deploy it in that unapproved layout. I'm guessing this is where something like certificate transparency would come in, and you would be able to use certificate transparency to monitor for certificates for your domains that shouldn't have been issued.
Right.
It worked for Facebook.
Right. I mean, that's basically happens. So that happens when certificate gets generated, right, from a CA. CA logs it into CT, right, so you monitor that. But that kind of happens much later, right? So the idea here is to essentially prevent that from happening and moving untrusted or unapproved images that run in production that have been, essentially signed with an unapproved CA.
So I think the most likely way that's going to be solved is through something like an admission controller on Kubernetes. Where
you guys are not planning on getting into that space to solve that problem?
Not at the moment.
Okay.
But yeah, the admission controllers on Kubernetes are going to basically allow a lot more flexibility on imposing a policy to all images. So you'd be able to have something specifically that says, like, when people are deploying these images, inspect them for this particular type of configuration, and maybe not even disallow it, like maybe just replace it with the correct one.
Right. Okay, thanks.
I think there's one more question down here. I think this will probably be the last one. The timer is starting to get angry.
Yes, thank you for this very interesting presentation. The vulnerability scanning, is it part of the community edition or is it enterprise edition?
It's part of Docker Enterprise. It's a feature in the Docker Trusted Registry, which is the on-prem registry.
Okay. It would be a way to make the world safer, to make that available to...
There are open source scanning tools available.
Yeah, okay. That's
I'll just leave it as, like, we don't have the right to make the scanning tools we're using available to the public.
Yeah.
So.
Okay, makes sense.
All right. I think the timer is saying we're done. So thank you all for coming.
Thank you.